last tutorial we created this function to delete the bullet whenever it goes outside of the window from the top. Now same kind of logic I will use to delete our enemy rectangle whenever the bullet touches it, or whenever the bullet and enemy comes in contact. If I run my game right now, you can see that whenever the enemy comes, if I throw the bullet, it will pass right through the enemy. See, right through the enemy, nothing is happening. But whenever I throw, this bullet will go out of bound when it touches the window's height, which is 0. When it goes beyond 0, the bullet gets deleted automatically. So if you see here, it says like bullet fired, bullet destroyed, because it's whenever it's going outside of the window, it's getting destroyed. So to destroy our enemy, I'm just gonna copy this function which was created to delete the bullets. Same logic, but instead of taking the bullet class, I'm going to take the enemy class, and I'm going to change this to delete bullet to delete enemy, and we're taking enemy class to take its instance. Okay, and then we're going to keep the enemy in enemy list, and enemy, we get the address of this, and it checks if enemy list, and then deletes the enemy list of that index, and also gonna replace, or also gonna remove the space inside this list. Say enemy destroyed. Okay, and we're gonna immediately change as enemy changed. Oh, looks good. Enemy list. Now we don't have this slot, so I'm gonna create this. I'm just gonna copy this, go to our controller header, and I'm just gonna paste it here and do void. Seems all right for now. Okay, seems good. Everything looks good. Now I'm gonna create a function. Go to your public slot and then add void check collision, and this function is responsible to check collision, and if the collision is detected, or if the bullet or rectangle comes in contact of any sort, it should delete the bullet and the rectangle. So I'm gonna implement this inside our controller CPP. See, we implemented this delete bullet inside the bullet function as well, because this bullet was getting deleted because it was going outside of the window. For the enemy case, it's different. We are just controlling the destruction through bullet and its position, right? So we can easily control it just from here, from controller class. So we have this check collision function. So what I'm going to do is I'm going to start let's say loop. I'm going to do the nested loop to check on bullets, and if it is in contact with the enemy, one by one. It's a slower method. You could do this in a way faster way inside HashMap, but then initially I thought that I could just implement the HashMap, but then I thought, because as it is a beginner tutorial, it will be better for you to understand it in a loop. So for int I is equal to, I'll take the size of our bullet list dot size, and I'm going to check if it's greater or equal to 0, and then I'm going to say, so this is it, or I'm going to do -1 here, because I'm checking from the last value of the list. So anything that is created last, I'm iterating to the last element. So whenever you delete something from that position, you don't mess up any indexes. For example, you deleted a bullet from the bullet instance list, which is bullet list, right? They have an index of their own. If you remove something, then it might disturb the index that it had earlier. So whenever you remove something from last, it automatically stays in place. So here what I'm going to do is I'm going to create a bullet pointer and store the bullet list dot the value that we get from this loop, and the first value we just storing it in this variable because it is of type bullet, right? And then I'm going to create a next loop because we need this, because I want to send this bullet inside our delete. If it is detected, then I need to send a type of enemy or type of bullet, right? That's why I am storing it inside of this variable. Or if this was not needed, then you didn't need to initialize this variable, just because you see you have to pass it through this function later on to delete. That's why we need a variable so that we can pass it through this function if the collision is found. Okay, and the next loop is to iterate over our enemy. So j is equal to enemy list enemy dot size also -1, so we are iterating from the last, and j should be greater or equal to 0. It shouldn't be empty, so because the index doesn't go below 0, and then j -, sorry. And similarly, we're gonna create a variable for storing enemy to pass it through this delete enemy function later on if detection is found, collision is found, sorry. And say enemy is equal to enemy list dot I. Perfect. And what I'm gonna do is I'm gonna create a bounding box. If you don't know what bounding box is, we're gonna allocate a variable to keep the position of our bullet and rectangle, and then we can check. We're gonna give a logical statement to check if any bullet or rectangle comes in contact or overlaps one another. So the logic is very, very simple. Generally, bounding box is used in game just for the to detect the collision. So it shouldn't be that complex. I'll write and I'll try to explain it to you in simpler terms. So let's move ahead and do it. Let's create a double bullet left, which is going to store bullet dot x and double bullet right. I'm just storing the the size of the bullet. So bullet, it gives the position of x, right? And then bullet, our bullet size is what? If I go to bullet.kml, is width is 10. Okay, I'll go back to CPP, so I'm going to add 10. So this is the size of our bullet from right. So this is the coordinate. We are getting the value of the position of right side of the bullet. And similarly for double bullet dot top, will have bullet y value, and similarly double bullet dot bottom will have bullet y plus what's the height of our bullet as 30, right? So I'm gonna say 30 plus 30. plus 30. Same thing, we're gonna locate the position for our, or the coordinates for our enemy rectangle. So double enemy left equal to enemy dot x double enemy right will equal to enemy. I noticed the size of 50, the width of the this enemy rectangle is 50, so that's why I'm adding 50, which is gonna give you the right position of the enemy rectangle. So this is gonna go over every enemy in bullet to check if there is a detection or not, or the collision or not. Double enemy top. This is I find this is the most easiest way to implement this enemy y and then similarly double enemy left, sorry, bottom, enemy dot y plus 50, because it's a square, right? So what I'm gonna do is I'm gonna have this if statement. Now this is the main logic behind the bounding box, so it's gonna check if bullet right is greater than enemy left, and all these four condition matches, then we have a collision. And I'll show you how this works. If bullet right is greater than enemy left, and if bullet left is less than enemy right, and sorry, bullet top is greater than enemy bottom, and bullet bottom is less than enemy top. So this is the major logic that checks the detection. If all these four condition matches, then it's either bullet touching the enemy rectangle, or it is overlapping it or trying to overlap. So if there is a collision here, I'm going to say, I'm just gonna call these functions to delete enemy, sorry, first delete bullet, and then we need to pass the bullet. So in this case our bullet is this, so bullet and delete enemy, and our enemy is enemy. So this delete enemy we just wrote right now, right? Same logic as delete bullet. So after this I'm gonna say break, so that or maybe I'll just do break inside of this here for now. And how this works is, I'll go to my browser and just create this big rectangle, and I'll create this small rectangle for the bullet. Now what is our first condition? See, when bullet right is greater than enemy left, when bullet right, which is this, when bullet right, this side, is greater than bullet left, that means greater than. If this is greater than, it will come here if it is greater than. And what else? And bullet left is less than enemy right, and bullet left is greater than, sorry, if did I mess up? Like bullet right is greater than enemy left, bullet right is greater than enemy left. That means it starts from I'll just write 0, 0. So it starts from 0, this side also 0, right? Top is also 0, this side is also 0. So if the bullets right is greater than enemy's left, if bullets, this is this right, this side is the right, if it is greater than bullets left, then what happens? If it is greater, then it will come inside of the bullet. This position will be inside of the bullet. And bullet left is less than enemy right. Bullet left means this is smaller than. Smaller means what? This side is from 0 to the width, right? Then smaller means this will come to this side, meaning that now this is bounded between enemy right and left with two forced conditions. So it is somewhere in the middle of the right and left of the enemy rectangle. And the other two condition, if bullet top is greater than enemy bottom, if bullet top, I'm going to change the color for this, if enemy, what does it say here? If bullet top is greater than enemy top, enemy bottom, if bullet top is greater than enemy bottom, that means that greater means what? This side, you see, this is the bottom, right? Greater means it is somewhere down there, which I don't like. So maybe I messed up here. So this should be opposite now. Yeah, this is how the logic works. So it is somewhere greater than the, less, the bottom of this rectangle is greater than the top of the rectangle. So another logic is bullet bottom is greater than enemy top. Bullet bottom is greater than means it is greater, means going this way, right? This is the greater side because it starts from 0, then it's greater, then it means that you have a collision. And in case of collision, we already did this part. And now I'm going to call this function inside our update here, because this is going to go in a loop with the timer. So you see this condition will help you check the collision. So if I run and play the game, let's see, we could, yep, see how this works. It automatically detects if the bullet is, now this is not getting detected, see, this is not getting hit. So I'm gonna just here, and do I need to emit change? Emit bullet, but we emitted this already in the function. Let me check the function again. Let me check. There is a function. Okay, we already called the function. In case of this, looks fine. Greater than 0, size gonna reduce. Oh, sorry, this meant to be j, because this is a nested loop, right? Let me see. Okay, now seems good. I'm gonna run again. So this is how I debug. I always debug in front of you guys. So now I don't think it would be hard for us to find the collision, because this bound box technique, I like this over any other techniques for collision detection. Now see, you can shoot over any other rectangles. So now for moving side by side, it feels slower and laggy. I don't like this. So in the next tutorial, we will make the side by side movement a bit faster than this. So I'll see you in the next one. Now you can hit the enemy and then delete your enemies like this. And we're also gonna use counter for counting the score. I hope you like this tutorial. I will see you in the next one. Thank you.